Hello friends, I am Professor Anil Brahmin from Sri Sankajaya Technical Campus, and in this video we will understand the very important divergence theorem. From the point of view of CSVTO and other industry examinations in the electromagnetic theory, this theorem is having too much importance. For understanding this divergence theorem, first we will just understand the definition of divergence, which is mathematically d dot ds surface integration divided by dv as volume tends to 0 is the definition of divergence. What does it mean is, if we are taking the integration of a surface vector to a very small volume, d dot ds for very small volume, it as volume shrinks to 0, the resultant thing is defined as the divergence, and which is coming out to be equal to the charge density rho v, which is defined as well known Maxwell's first equation, which is divergence of D, which is electrical flux density, equal to rho v, which is the volume charge density. Now, by taking the volume integration on both sides of this, we will have volume integration of divergence of d dv, and here we will have volume integration of charge density. This volume integration of charge density is basically, if we are traveling from say this small volume to bigger one, we will have the total charge enclosed in the volume. This integration of rho v dv becomes total charge enclosed. And now, just by knowing the Gauss law, which is telling us the total charge enclosed is surface integration of d dot ds, electrical flux density dot ds. Now, thus from here we can have the relation of volume integration and surface integration. From here we will have the divergence of d, volume integration will be related with the surface integration, and this is very important relation in the mathematics also, which is correlating the volume and surface integration of the vector. And this is the divergence theorem. The basic meaning of divergence is something spreading in the atmosphere, or we can say फैलाव जो होता है वो divergence है. And to this small volume we are having rho v, and if we are going to the bigger volume, it becomes divergence theorem. As we have seen, for the bigger volume it is a total charge enclosed. Thus this is the divergence theorem, and in this way we can explain the divergence theorem in different examinations. Thank you.